Hi, my name is Milos and welcome to Element 14 Presents. Today I'll be showing you how you can control things in your room using this. This is a Raspberry Pi Pico W and this is just a standard Raspberry Pi. So my goal with this project will be to control things like the lights, the blinds, opening up and closing the window and having all of that control on my phone. I'll begin with the layout of my room. So first the furniture. Of course we have the bed, the cupboard, the tables, the shelf and the couch. So the main things I want to control here are the lamp and the windows. So for the windows we have the Venetian blinds, the outside blinds and the opening and closing of windows, and I want to control the light on and off. I'm going to use a Raspberry Pi 3 as a server connected to the Ethernet switch. I'm going to have a main node controlling the blinds and light, and I'm going to have another window node using MQTT that will control the Venetian blinds and opening and closing the window. Here is our simple MQTT test setup. So we have the Raspberry Pi Pico, the W version which has Wi-Fi, an SED40 sensor which can measure the CO2 levels, temperature, humidity and an LED. Here on my phone on the left you can see a simple interface that I'll show you how I made that can display temperature, humidity, CO2 and have a button for controlling the LED. What we want to do with this setup is actually get a two-way communication, so we can actually send the commands over MQTT to the Raspberry Pi Pico and receive the sensor data on our graphical interface. Let's connect up the Raspberry Pi Pico and wait for it to connect to the Wi-Fi and the server. You will see the values update since these are from last night when the temperature was quite a bit lower than it is now. So let's just give it a moment to boot up and to do its thing. Okay, so the values have updated. So as you can see, the temperature in my room is around 20 degrees Celsius, relative humidity 43%, and we have the ppm level of around 906. And if I press the button here, you can take a look at the LED that it's turning on and off. This is the essential block for building the whole automation system for my room, so I'll go into details how I programmed the Pico and also how I actually made the server run in Node-RED and set up MQTT. So how does MQTT actually work? In the center we have the MQTT broker, which actually coordinates all of the messages. We have topics which are channels on which we communicate, and we can either publish or subscribe to them. If we publish, we send data over them, or if we subscribe, we read the data coming from the broker. So for example, we publish sensor data and we subscribe to commands coming from the graphical interface and things like that. So that's a short version of how MQTT works and how that previous experiment worked. Let's look at how I accomplished this in Node-RED. Okay, so now we're looking at the things that are running on the Raspberry Pi 3 as the server. I like it running just Linux so I can test out stuff when I need a Linux computer on it and things like that. This here is Node-RED. I've given my Pi a static IP address, and as you've already seen, it's connected to the switch, so I can connect to it with my computer at any point. Node-RED is flow-based programming, and it's incredibly easy to start and to configure things like MQTT just by using these two nodes, MQTT in and MQTT out. So the test you've seen, this is the button for turning on the LED. Some notable things here are to place them in a special group and things like that, but you can see that when you actually go and make your own button, you need to place it in a special group, and that also group needs to be a part of a special tab. And then we just add the MQTT out. This is the server that we need to type in, and we just added the topic that the Pico will listen to. The other way around, Pico will send the sensor data on different topics, these three topics in this case, so temperature, humidity and CO2, and we captured those sensor readings and show them on gauges here on our GUI. So how the GUI is actually made automatically. Here you can configure things like the units, the range, color gradients and things like that. And if we switch tab to our GUI, you can see the current temperature reading, humidity reading, and the CO2, as well as our button. So it's incredibly easy to start with Node-RED and to configure something like that. I know there's Home Assistant and other more developed softwares for things like this, but I only want the basics and really don't need anything else, but I can always build upon this if I want later on. We're looking at the Raspberry Pi Pico W code now, so all it needs to do is actually communicate with the Node-RED over these topics. So we're gonna subscribe to this topic to actually see when the button is pressed in the graphical interface, and we're gonna send our sensor data to these topics here. This is built upon the DFRobot SD4X library because this is the sensor I'm using for the temperature, humidity and CO2 levels. So you can find this code down below on Element 14 community. This is a simple code to just test out everything to make sure everything works. So you just need to put your SSID and password for the Wi-Fi network. The Pico W will connect to Wi-Fi and will also connect to your server. My server is set up with a static IP address, so that's how I connect to the broker, as you can see here. Once we've connected, we can also then subscribe to the LED topic so we can know when the button is pressed or not. And of course the rest of the code is just around the SCD40 sensor. Besides that, the SCD40 sensor readings are done all in a loop. I also have a timer function that is at 10 Hz in this test code, and it just checks 10 times a second if there's any new messages on any of the subscribed topics, and if there is, it extracts the message and it just toggles the LED on and off. You will see later on how you can actually extract that data and use it to turn a servo an exact amount of degrees or set some parameter or anything like that. Now that we know how to send and receive data between these two, we need to figure out how we're actually going to open the window and open and close the blinds. So we'll need to design some actuators. This will be our next step. So this is the first of the actuators that we need to design. This one is for the Venetians. So how do actually Venetians work? They have these light blocking elements that change their angle depending on how much you spin the axle that you see on the top here, and that's usually done with a wand. So what we need to do for our actuator is actually mount a motor that can spin it either in one or the other direction. Because we need to spin it multiple times, we can't just use a position servo. So for this I will be using 360-degree servo, meaning it can do multiple rotations. But there's another thing that we need to watch out for, and that is how much it actually spins. The proper way to do this would be an encoder, but I don't need that kind of precision. So instead I opted to use a small micro switch, which will get triggered as the motor is spinning, as you can see. We know the direction of spinning. It will change based on if we're opening or closing. We just need the relative position of how many clicks it goes one way or the other. Let's look at the CAD model for this. This here is the design for the Venetian actuator. So as you can see, this is the main part, the servo motor. And as you've seen in the drawings, here is the micro switch that is triggered by this coupler right here. It has 4 of these small bumps that will trigger it. We can add more, but 4 is sufficient enough because I need a whole number of turns. It gets mounted to the servo mount here, and this part here, that's the window mount itself. To make it just look a bit more pretty, I just added a cover for the servo motor like this and a cover for the window mount, and this is how the whole unit looks like. This down here is just the place where the cable goes through, so we can actually power and control it. Let's take a look at the bench, how this actuator performs. I've printed all of those files that you've just seen and assembled the actuator. So these are the main parts, the inner workings that actually hold everything together. And here, if you look closely, you can see the micro switch being triggered every quarter rotation. So I just wired it up to a 4-pin connector so I can do the wiring later easier in my room. And these are the covers for this actuator. Here on the side I have an actuator that's for the other window, so make sure to mirror all of the parts when printing them. So this is a completely assembled unit. Let's now go ahead and test this one. I've just added a few buttons like I showed you before for the LED. So let's just connect this to the Raspberry Pi Pico. I've connected it to the Pico. It's running the similar code to the first test, where it just accepts these button presses as inputs. So if we press up, for example, I've put a set amount of clicks that it needs to go before it stops. You can see it spinning right here. So it stopped, so now it thinks it's in the up position. If we click up again, it won't move. If we click middle, this is the open position for the blinds. It will do half of the clicks like the last time. If we go again up, it will continue in the same direction and do half the clicks, or if we go now down, it will do the max amount of clicks.
Do you like free stuff? You can join the Road Test program. You can get free dev kits, test equipment and even online training courses in exchange for a detailed review. Join our Road Test program. Learn more at the link below. Free stuff.
So for the other actuator, I actually want to open the window and close it. This is the window motion that I want to achieve with the actuator. I want to mount it as high as possible to be the least visible as possible, and for it to need to use the least amount of force, but that means it will need to have a longer travel, but that doesn't matter to me. So I'm gonna use the 360-degree servo like I did for the previous actuator, the same thing for the switch, and I'm gonna use a rack and pinion system. So the servo will be mounted with the pinion gear on the window itself, while the rack gear will be mounted to the window frame on a swivel or a bearing, so that when we trigger the system, the servo will travel up and down the rack gear, opening and closing the window. And here we have the actuator for the window itself. So just like in the drawing, we have the rack gear, as you can see here, and we have the pinion gear that's spun by the servo motor. We have the same protrusions here that triggered the small micro switch. To hold it in place, I've put this bearing here. It's supposed to keep the rack gear aligned, and I've only put one bearing here so that the whole rack gear can move up and down, because the angle of the window changes as it opens and closes. This part here with the motor itself mounts to the window, and this small part here actually mounts to the window frame, and it has two small 5mm bearings here so that the rack gear can spin around. And of course, just to make it look a bit more pretty, I've also modeled this, which is a cover for everything. So this is the only thing you will see in the front, just a small cover and the rack gear when it's closed, or literally just the cover when the window is open. And of course, at the top there's the cable routing. Let's go and test it on the bench. And this is the assembled window actuator. So you can see the rack gear and the pinion gear. So as you've seen from the CAD model, the rack gear is actually made out of two parts because of this guide rail, so that there's no support material. And there's just a single bearing here to keep it in line. I didn't want to use two bearings because I want some leeway in this direction, because the window changes angle as it moves. Besides that, it's the same as the Venetian actuator. It's the same servo and the same micro switch with the same dimples. This is just the cover that goes over like this, and it looks like this. It goes over the window here, and this is where the cable goes out. Let me connect it to actually test it out now. Now that everything is connected, we can press the up button and you can see the actuator working, or if we press the down button, you can see it going in the other direction. So this here is the spaghetti box. You probably have an idea why is it called like that. Let's open it up and see why it's called a spaghetti box. And yep, that's because there's a lot of spaghetti inside. I made this box originally 5.5 years ago, back in September 2018. I even wrote a blog about it in March 2019, and it's been working ever since. It has an 8-channel relay module inside, with each channel having its own dedicated switch and fuse. It also has an IR receiver and a photoresistor for measuring the light. One thing I love about this is that a lot of people love to say that Arduinos don't work, they're not reliable, the project will die after a few months. This has been here since 5.5 years ago, and it's still working really good. I won't be changing it out now for anything newer or better like I'm doing with the rest of the system, doing MQTT and things like that, just because this uses mains voltage, and I'm gonna do new installation, new paint in the room, things like that, and when I update all of those, I'll then do all of the cabling and then I'll update this box as well. So for now this box will stay like this, and I just love that it's still working after 5.5 years. Let's take a look at the schematic of the main node. I just need to warn you, this is working with high voltage 220 volts in my case. It can be seriously dangerous, so please be careful and don't do this if you're not experienced. Each of the relays has their own switch and fuse for protection. The first relay is for the lamp and the other two are for the blinds, which is tied in parallel to the physical switch. There are 5 more relays that can be used for anything else as just an expansion. If you want to find out more details, you can find the full blog that I've written a couple of years ago on this topic, so all of the information is still relevant. This is the full schematic for our Raspberry Pi Pico W node. It's pretty simple, so the main part is the Pico W and it just connects to the rest of our modules. We have the SED40 sensor, which just communicates with the Raspberry Pi Pico over I2C. Besides that, there are 3 connections to the servo motors. So each of the servo motors gets the 5 volts power from the power supply that's here, and it gets a PWM signal. Besides that, we only need to read the switch input. I could have just used a voltage divider using 2 resistors, but I decided to use a small optocoupler like this, just to drop the voltage down from 5 volts to 3.3 volts, so I don't damage the Pico W. So that would be the full schematic. Before we get to the testing, let's check out the software. These are the libraries I will be using, the pins. So you can find the full pinout and schematic as well as all of the codes and CAD files on the link down below on Element 14 community. These are the parameters I use for fine-tuning how many ticks is either the Venetian blinds or the window ticks, so you can increase or decrease depending on your case. You need to put your own Wi-Fi credentials here, and these are all of the topics used in MQTT. So how I like to program the Pico is using timers. So this timer gets called 100 times a second, that's how I have it set it up, and it just reads if there are any changes on any of the switch pins, as you can see here, so we can do all of the counting, and it also checks if there are any new messages on the MQTT topics that we're subscribed to. To subscribe to the topics, we need to subscribe to them in the setup function here. The setup just goes setting all of the PWM channels, setting all of the pins, setting the Wi-Fi and the MQTT. As I've mentioned before, I'm connecting to a static IP address of my server like this. I suggest you do the same with your Raspberry Pi if you're gonna follow along. It's the easiest way to do all of this. And the rest of the loop function just reads the data of the sensor and publishes that data onto the topic. I've just used the example sketch. Before we get to testing, the only thing left to do now is check the graphical interface and the Node-RED code that goes with it. Okay, so the last thing that we need to look at is the Node-RED flow. So here are all of the nodes that I will be using. This section right here communicates with the main node. So you can find the code linked down below. The Arduino actually is hosting a small server with a static IP address, and just by sending these requests I can either turn on or off some of the relays. So that part is pretty simple. And here I'm just using basic Node-RED buttons. This section right here in the middle, this is for the communication, for sending controls to our new node, to the Raspberry Pi Pico W node. So we are sending data over the topics to which the Pico W is subscribed, as you can see here. So we send data every time a button is pressed. And in the end, to actually read all of the data, we have this part right here, which is subscribed to these topics here and shows them on different gauges. Besides that, because I want to have multiple screens, there is also this, which is an internal command. It sends a JSON command that looks like this, which actually switches between multiple tabs. And on the other tab that I will show you now, I have the same thing, but instead of my room 2, it just has my room, so it can switch back to the main tab. The idea with the second tab is to have a bit more details that you don't want to see at every point. So we have temperature, humidity and CO2 graphs which track all of that on a 24-hour scale or the last 1000 readings. Besides that, with this part here in the middle, this gives us the data on when was the last time that the Pico W actually sent some information to our server, so that we know that it's functioning properly. You'll see that in the graphical interface soon. This part here is the thing I just described for switching to the main tab. And because I'm running the Raspberry Pi without stopping pretty much, I wanted to have some info on it, and every second, as you can see with this node here, I have this big contraption which runs some shell commands to get how long the system was on, the temperature, the CPU frequency, and things like that. I'll show you now the graphical interface and it will all make a bit more sense. Here you can see the main controls, which is the light and the blinds. Here on the right you can see the new controls for the Venetians and for opening and closing the window, and in the middle you have the current readings of temperature, humidity and CO2. Just the basics, and the button for switching to, I'm calling it the details tab. If we click it, we switch to this tab where we can see some more additional info if we're interested. For example, you can see the graph for the temperature or for the CO2. And from the CO2 graph you can literally track when I opened the window or when I entered the room, exited the room, and things like that. And here's the server info I was talking about. So the Raspberry Pi is working non-stop for the last 10 weeks, 4 days and 59 minutes. And it's doing that without breaking a sweat. And here in the top you can see the last time the Pico W actually updated, communicated with our server, which was less than a minute ago. So that works, and with this button we return to the main tab. Now we can finally test out the whole system. So we have the light control. I'll do all of the controls on my phone. As you can see, the light is turning on and off. We can put the blinds down. You can hear them going in the background. We can stop them and we can make them go back up. Also, since the windows are the main focus here, as you've seen through the video, we can close the window and we can also open it up. And of course, if there's too much light and we don't want to use the full outside blinds, we can just use the Venetians like so. And there we go. So, but yeah, it's a little bit dark now, so we can just turn on the light. So everything works. You also saw both on my phone and on the PC screen, I also have all of the temperature data as well as the humidity and CO2 levels. And I can also do other things like automate for the Venetians to open up early in the morning when my alarm goes off and things like that. Thanks for watching the video. I'll make sure to update the main node and I'll post an update on that as well when I redo my whole room. But for now you can find all of the files down below on Element 14 community. If you have any questions or comments, please leave them down below. This is a project that I will be using on a daily basis, and the part of it, the main node, I've already been using it for 5 years. So see you next time. Bye!